and welcome back to another Knife Making Tuesday. I'm your host John Grimsmo, and here's a quick sneak peek at what we're going to be doing this week. Should be awesome. I do apologize for the 1 month hiatus, but this is why. Hey guys, so this is my daughter Clara. Clara, say hi. Say hi. Hi. So that's Clara, and this little guy is the reason that I've been offline for the past month. His name is Leif Grimsmo, 3 weeks old. So with 2 kids running around and lots of stuff to do, it's been hard to get work done, and especially hard to get the videos done. But he's worth it. Look at him, he's adorable. So, there we go. But now I'm starting to get back into the swing of work, so let's get some video going. So here's the plan for today. I am making Norseman handles. First operation is to do all the backside. Bearing pockets, screw holes, all kinds of stuff in the back. For my first 2 batches of Norseman, I got all my handles waterjet cut. So from a big sheet of titanium, send it to a waterjet shop, and you can see up in the corner of the screen there's a piece of titanium that's been waterjet, all the outlines coming out of there. So I used to do that, and it's got 2 mounting tabs on the outside for clamping it down. There's mostly pros to this, but the cons are you're paying quite a bit for waterjet costs, and the way I had my clamps on the outside here, if you're ever going to get handles waterjet, keep this in mind. 1/8 inch titanium, just clamping on the outside, clamp it down to a fixture really tight, it would actually bow it up in the center by a few thou. Enough to make a difference on some of my parts. And that got really annoying until I figured it out. Knife maker RJ Martin helped me figure that one out. So if I were to do this again with waterjet, I would clamp on the outside, and I would also put a little clamp right here and a little tab right here and here to clamp down the middle. You don't need a lot of strength down the middle, you just need something just to tick it down that few thou. Especially if some of your tolerances are really important. Especially the lock bar cutout here. You know, I'm shooting for 40/1000ths of an inch for that thickness. And with the first few batches, it was all over the place. And it turns out it's because of the bowing. So flat is good. But for this batch, I'm going to try things a little bit differently. I got some pretty cool tools in the shop here, so I'm going to use them as judiciously as I can. So here is a piece of 1/8 inch titanium, 18 inch by 10 inch. This is the entire working travel of my Tormac, so I can access every square inch of this, every corner for machining. So I want to be able to machine my handles from scratch by myself from this. To do that, we're going to use the Mitee Bite vacuum table. Now here's a vacuum fixture that I made, which fits the Tormac perfectly and has my 18 by 10 inches of travel. So, oh, this is heavy. Basically, my titanium will suck down onto that with about 2,000 pounds of downforce, and should be awesome. However, I have a stack of waterjet handles left over from the first batch. So what I did is I made a quickie fixture that bolts onto my vacuum table. That lets me bolt these old waterjet handles on and the clips on. Notice here I installed some small M4 bolts. They don't have tabs on the handles at all, they're just sort of pinching on the side, which certainly isn't ideal, but like I said, there's not a lot of clamping force required there. It just needs just the tiniest bit of pressure to keep it flat. So yeah, this will let me not only test out my new code, because I'm doing things quite a bit differently than the first batch and the second batch, but it lets me make use of the waterjet pieces. So for the testing especially, I don't have to potentially ruin that big sheet of 18 by 10 titanium. I get to ruin these small waterjet pieces left over from before. So sure it's clean on the bottom. That's that. So now that I've got it installed on the base, flip the switch. Now of course this is a vacuum table. All these holes do not go all the way through. The only one that goes through is the one in the center, and I have a screw in there holding it closed. So the plate does not have any vacuum going through it, it just has vacuum sucking it down to the table. Turn it on, I'm pulling about 21 and a half inches right now, which is way more than adequate for what it's doing right now, just to hold the fixture down. But yeah. So turning the vacuum on, all it does is holds this big plate down to the blue thing, and my little sub-fixture here is screwed on quite tightly. So I'm going to probe the fixture so that I have a location, and then I'm going to probe the top of the workpiece so that I know exactly how thick it is and exactly how deep to machine from the surface. Okay, so like I said, the first operation is a probing routine. This is Tormac's passive touch probe. I love the nice big shadow under here from the ring light that I've installed. So you're just going to have to look real close to be able to see through that shadow, but well, there you go. So it just recorded the location of those 2 points, and now each handle has its own different offset in case the thickness varies by a little bit, so that when I machine a bearing pocket, it machines the pocket exactly down whatever I want from the surface, regardless of how thick the material is, which is very, very important. For one of the operations that I'm doing on these handles, I'm going to use a 1/16 inch reamer. This is a high-speed steel reamer, and typically reamers have like a pointed tip, so you can't get to the bottom of a really blind hole, and I want to get as far down into the hole as I can, almost touching the bottom and reaming all the way to the bottom. So what I'm going to do is I'm going to take my disc sander. I've already started a little bit, and I'm just going to sand that taper off. Obviously not all of it off, because you need a little bit of taper to get into the hole and start cutting, but I'm going to sand as much off as I can. Here's the pin that I'm going to be using and the reamer. And you can see how the pin has a bit of a taper to it as well, so I tried to match that with the reamer. Although I think I took the reamer a little bit farther than I need to. But it's still got just enough taper to get into that hole. And to give you an idea of how small these are, I mean, that's my pointer finger. You know, that's my thumb. These things are huge. These things are tiny. Done. I shortened it down. Now it's quite a bit shorter. It goes into my drill chuck. Tighten it down. It's still got plenty of overhang. You know, a reamer, it's typically really long so that it finds the hole and is allowed to flex and find its way in. It doesn't do any centering of the hole at all. It'll find the hole, and even if it's quite off center. But with the CNC, everything's, you know, really precision anyway, so I could have this thing really short and it would still work great. So that works awesome. So what it's doing now is it's got a 1/16 inch 4-flute end mill, and it's interpolating the holes bigger. So all my drilled holes are now getting precision bigamized to a perfect diameter. These holes right now are the ones for the spacers, the back spacers. That didn't work. Shoot. So there's a very good chance that my reamer flattening technique sucked. Or the hole was too small. It's a 55 thou hole for a 1/16 reamer. I think that was too small. Huh, bummer, dude. Yeah, both those two combined definitely are what broke it. Also notice how the spindle's on right now, it's feeding down, then the spindle stops, and then it retracts. I read online that's how you're supposed to ream. It gets a tighter hole. Crap. Well, I'll have to pull that chunk out before it breaks something else. So I just pulled this one out. I'm gonna keep it as a souvenir, basically. I'll have lots of pocket clips, so I'm not too worried about having enough of these. But yeah, I think the hole was definitely too small. I was using a 55 thou drill bit for my detent hole, so because it was already in the tool changer, you know, I wanted to use it for these too. I don't have an extra spot so that I can use a like 60 thou or 60 thou or 61 thou drill bit. I think I read for 1/16 reamer you want to have 1.5 thou undersized hole, and my hole was like 7.5 thou undersized. So you could hear it just struggling, and with my sort of crappy flattening job of the tip of the tool, that also caused it to break. So what I think I'm going to end up doing is continue drilling them for 55 thou because I have that in the tool changer, and then there'll just be a manual operation later where we probably use a drill press and just manually drill it with a 61 thou drill bit or a 60 thou or whatever, and then manually ream it, and that'll be fine. Okay, so I pulled it out. I'm just going to run it without, it's going to air cut that spot, no big deal. Next up, tool number 9, the bane of my existence. Okay, you can't really see it, but tool number 9 is a 440 thread mill. Now, if you've been watching my videos, I did one mid week 50s, I think week 55 or something, called thread milling fail, where I just kept breaking these things. I have finally figured out the recipe for perfect thread milled holes. And I've gotten it to the point where I'm confident enough that I could do an entire pallet of handles on the same thread mill without any fear of breaking it. So that is fantastic. Thread milling is interesting because it's fairly commonly talked about on the internet, but there's not a lot of documentation about it. People explaining, you know, exactly how to do it and figuring out the calculations and formulas and all that. But if you look hard enough, there are some really good documentation. Harvey Tool and Advent Tool, something like that, has really good documentation for thread milling. So look into that if you're not sure. And yeah, but important things are having the hole the exact right size, and for harder metals like this and a small tap or a small thread mill, do several passes. I'm doing 3 passes and a spring pass. I'm going wider and wider, bigger diameter on every successive pass, and specifically calculated to take an exactly equal amount of material per pass, because it's a triangle wedge cutting, and the deeper the triangle goes, the more material it goes, so you gotta kind of compensate, and I don't know, I've got it all in a spreadsheet. So I'm going to do some thread milling, and with any luck, it's no problem. Even after figuring out all those settings, I did my first thread milling job, and I did 1 hole, 2 hole, broke on the 3rd hole, and I figured out it was getting too close to the bottom of the hole. I had a 2 thou clearance at the bottom of the hole, which is nothing, it's like half the thickness of a human hair, and chips were probably getting underneath the thread mill, because it does a pass, retracts, does another pass, retracts, and you know, maybe if one chip got underneath the tool when it goes down to 2 thou, it just snapped. So I gave it 6 thou clearance now, and it works fine. check it out. 440 screw. Threads in like a boss. Perfect thread diameter. It took about 3 different tries to keep opening it up and opening it up to get that perfect thread, but now it is just fantabulous. Love it. Very strong thread too. Love it! Okay, next up we're moving to an 1/8 inch flat end mill 4-flute, obviously from Lakeshore Carbide, and this is going to open up the bigger holes, like the bearing pocket, no, not the bearing pocket, the pivot hole, the stop pin hole, lanyard hole, stuff like that. And it's spiraling down into the hole. You can see it speeds up a little bit for the finish pass. Beautiful. So right now it's roughing out the clip profile on the bottom, and then I'll go in and finish it up with a ball end mill, really pretty like. But the flat end mill is just better at roughing it out. Speaking of ball end mill, so this is doing a linear 3D milling pass with a 20,000 step over, just going line by line by line to 3D contour the bottom of that pocket clip, which makes my pocket clip super duper beautiful. Yeah, you can see it taking shape already. So what it's doing now is engraving our super secret brand new logo onto the inside of the handles. This is the unveiling of this logo. I'm really, really excited for it. I think it looks awesome. I don't even know if you can tell what it is from here, but I'll close up later. Now it's going to label the parts. It's going to say Norseman, March 2013. And now it's engraving super secret stuff onto the inside of the pocket clip. I figure I have CNC, I love CNC. Let's engrave everything, make it as cool as we possibly can. Leave little surprises for all you future owners out there. Why not? It takes an extra minute. Next up is a 1/4 inch mill drill, 2-flute, to do a bunch of chamfering. All right, been making some awesome progress. That is our new logo, my friends. I think that's about the coolest thing I've ever seen. That is a brand. Love it. Pretty fitting on the Norseman knife to have a picture of a Viking / Norseman. So yeah, things are going pretty well. Clips turned out great. So just in the backside of all my parts, of my handles and my clips, there's a ton of machine time. I'd say I spend more time machining the backside of my stuff than most other knife makers do. I get a little crazy like that with doing things over the top and sort of pointlessly excessive, like this milling here. You know, that takes quite a bit of time, but the result is awesome and I love it. For anyone thinking of making a pocket clip similar to this, but if you want to do it an easier way, is instead of laying it flat on your fixture, make a fixture that lets you mount it up to the side. So that when you take your end mill, it comes down and you can just do this in one single pass. And then you have an awesome profile with a hump and everything, and it's done in one pass, whereas this takes quite a bit of time. You know, doing it this way would be probably 10 times faster. But I'm all set up to do it this way, and I like doing it this way, and I think it looks really cool. And the way I've got my pocket clip set up, I have to do thread milling and drilling on the backside anyway, so that there's no screw holes coming out the front. I think that's going to be awesome. My old clips had screws facing out the front. Not a big deal, but I think it's going to be even slicker to have no screws. They get screwed in from the backside. But yeah, if you're going to make, you know, if you want to make an easy pocket clip, mounting it sideways with tabs, 2 tabs like this, would work great. And I've certainly thought about doing it, but like I said, I'm all set up to do it like this, and I want to keep doing it like this for now. Maybe for another knife I'll do it different. What else? So the next step for us is to finish machining the waterjet blanks. We've got, there's probably 14 left or 13 pairs left. So we'll finish machining those, and then we'll work onto the big sheets and machine those. And that'll be tomorrow's project, but that will not be in this video, that'll be in next week's video. And then also in next week's video, the next step to these handles is mounting them on the next fixture so that we can machine the top side. Now I've got 2 identical fixtures here. These are my Norseman handle topside fixtures. Let's see if you can see right here. There's a pin, and right here is a pin. 3/16 on this side, 5/32 on that side. And basically that mates up with the 3/16 lanyard hole and the 5/32 stop pin hole. And then it slips on there just like that. Now it's positionally accurate. I can't even hear it wiggling, which is, oh, so perfect. And then all those thread milled holes that we did, all those blind threaded holes, made to these holes in the fixture, so that I can sneak in there from behind with these screws, sneak in behind the fixture and screw the handles in from behind, so that there are no clamps on the top, no screws, whatever, and I can do all my topside milling in one operation while the entire handle is being held down completely flat. If I want to, I can even run a facing end mill or a face mill over the top and smooth it out, take out all those minor little scratches and stuff. So I might just do that, but yeah, that was kind of the whole point of doing it this way, is so that I have no clamps or anything and I can do it all in one fixturing. But in retrospect, I'm probably spending considerably more time doing all this thread milling than I would swapping around to various clamps on the top side of the handle. So yeah, in retrospect, this is a more time-consuming way to do it, but it's kind of awesomer, and I'm kind of a sucker for doing things the awesomer way, even though it's probably the worst way. Anyway, it's gonna be great. I'm really tired. I don't know if it comes across. I've not been sleeping much lately. What else? Okay, I'm gonna start wrapping this video up, but there's a few more things I want to show you guys. Finally got our blades back from heat treat. They were there for far too long. But they look fantastic. They got a slight golden tinge to them from the tempering process. But they measured a bunch of them, and they're all at 60.5 Rockwell, which is absolutely perfect. So yeah, there are 65 blades here. Some lefties. One of them has no thumb stud by special request. And these three over here. Booyah. These are our Damascus blades. They have not been etched, they have not been polished or anything, and just the heat treat process brought out that awesome contrast. Just wait till we etch these things. Dang. Dang! Especially like on the spines. Let's see if we can get in close here. The loops are kind of concentric. Can you tell? It's hard to tell. Just the pattern of the steel, it's concentric left to right, which just looks really, really neat. I don't know, I can't wait to polish these things up and etch them, and then mill the blades again. See how the step over here is quite large? Although it does look kind of cool that way. Our finished blades are designed to have a much tighter step over. This is a bad example. But yeah, much tighter so you can almost not see it so much. Then again, there's nothing wrong with a knife with these steps. I mean, they're a little ribby, but they're not that big. I think some people look at my knives and think, oh, they've got such big ridges and steps in the blade. Must cut like crap. I haven't found a single thing that is a hindrance on. I cut food, zip ties, paper, anything. Wood. Nothing's been a problem for it. Anyway, Damascus looks freaking amazing. I'm going to have to make more Damascus blades in the future. Faux show. Okay, lastly, I have this pile of goodies to show you guys. A few weeks ago, I think it was the threadmilling fail video, maybe week 55-ish. I was trying to make a certain part, and I just couldn't do it because I was trying to mill a part that is designed to be turned on a lathe. I was trying to cheat and do it on my Tormac. So in the end, I had a friend make these for me. He works at a big machine shop, and he's got access to all the cool toys. So he was able to make these out of titanium for me. I sent him some titanium bars. So what this is, you can see how small it is. It's basically a screw. It's got 440 threads on the bottom. He said this was very fun and challenging to turn on his lathe because those threads go as close to the shoulder as humanly possible, and he did an awesome job doing that. And then it's got a 3/8 inch head, and then the nubby here is just from where it gets parted off and then breaks off. So this will get machined off. And then the next step for me is to make a fixture with a bunch of drilled holes in it and tapped. And then I'll thread this into the fixture. I can do like probably 100 of them in one fixturing. I'll mill off the little tab, and then I'll drill and mill a Torx T10 pattern so that I can use a Torx screwdriver to get these in and out. So it will be a fully fledged titanium screw that goes on the inside of the handle like so. And this is my Hinderer lock bar stabilizer. Now, although I do have an actual license from Rick Hinderer to be able to use his lock bar stabilizer, the design is quite different than his. Mine's on the inside, his is on the outside. Mine's made from a single piece, his is made from a washer and a screw. So I don't know if it's exactly, if it falls under his, it's not a patent, but it's sort of just a good faith agreement. But either way, I don't mind. I'm giving him props for that, but because it is a really genius design, I just like my design better having it on the inside. So it's hard to thread in because I have nothing to grab onto, but once you get a T10 Torx in there, it'll thread in perfectly. And then what that does, if you don't know what it does, frame lock is spring loaded. This is the lock bar that prevents the blade from closing, but it's spring loaded, and normally you can easily move it too far. And if you move it too far, it'll lose its spring tension, and then the blade's just not going to work. So the lock stop, basically, imagine putting a plate right here, and it prevents the bar from moving all the way over. My solution is just prettier, puts it on the inside. I'll anodize some blue or something crazy so that you can just see them inside the gap there, and maybe when you look in like that. But otherwise it's completely hidden and awesome. So very excited about these. This has been a big challenge for me to either make these or get these made, and it seems to be working out really, really good so far. Okay, that's enough rambling. Yeah, I need sleep, so I think I'm gonna cut it here, guys. Okay. Yeah, 2 kids is a lot harder than 1 kid. People say that, you don't know how to interpret it until you have 2 kids, and it's twice as hard. Individually, dealing with each kid by themselves, no big deal. When you get them both together and they're both trying to sleep, or they're both hungry, or they're both crying, or whatever, that's when it gets stressful. But anyway, the kids are great, and life is good. I just need more sleep and need more time to work on my business here. But I'm figuring it out, you know, figuring it out. And finally this batch is getting underway big time. You know, the blades are almost done, the handles are well on their way, we just got to produce them now. I got one little tweak to make, and then we can just run pallet after pallet of handles. You know, we're making 65 knives, which is a ton for us. So, yeah. Anyway, guys, thank you so much for watching. Thanks for being a part of this YouTube series. Thanks for supporting Grimsmo Knives. Thanks for commenting. Thanks for just being awesome. And, you know, quite often I get helpful hints in the comment section, and I really, really, really appreciate that. So, there we go. See you next week. I've been filming a few side videos. Probably got 3 or 4 that I need to throw together and edit at some point midweek. Not anytime soon, but just so you know. So, alright, I'm going to sleep. Thanks, guys. Bye.